Hello, welcome back to the LOOC. In this segment, we are continue looking at inheritance, and we are going to redo our base plus commission employee class, which was derived from the commission employee base class, but instead of protected instance variables, we are going to use the original private instance variables and have another approach to inheritance. So the reason for this is because the use of protected instance variables have some problems. A derived class can set these values without validity checking. So the advantage of having validity checking in the base class is lost. And another disadvantage is that derived class methods need to be written in a way that depend on the base class's implementation of its data, and therefore if something changes in the base class, then these changes have to be rippled through all of its derived classes, and that will be a lot of work and a major maintenance issue of the code base. As a principle, we should be able to change any implementation details in a base class without any effect on the derived classes, and any change of implementation in a base class should be invisible to derived classes, and they should be oblivious to that. In other words, we want to use base class services. So declaring them private as opposed to protected of instance variables in a base class is a better way of going about inheritance, because the implementation can change without affecting derived classes. So we are going to do this in the next attempt to create a derived class. So we return to the original version of using private instance variables, first name, last name, and so on, all the way to commission rate. Have a 5-parameter constructor as before for the commission employee class. Note that this time the class stands on its own, so its class name is not followed by a colon and then the name of another class. So it looks like it's not inheriting from any other class, but in fact it is, because every class inherits from object if there's no other base class indicated. So colon object could be there for explicitness, but even without explicitly specifying it, our class inherits from the root base class object. Then there are the properties unchanged that make public access and where allowed changing of attributes and instance variables possible. It also includes validity checking, so only non-negative values are allowed to gross sales, and only values between 0 and 1 are allowed for commission rates. Note that the earnings is now a virtual method to allow inheritance and overriding, and we return the public properties when we are calculating the earnings. So it's important to see this difference, that even though there is a private decimal grosses and private decimal commission rate, that's not what we are using in our earnings method, but instead we are relying on the public properties that have public accessors and mutators, and this change will allow the overriding of this method in a base class, yet without requiring a protected access. So we can stay with private access and limit access to this class only, but by using public properties, instead of protected instance variables, inheritance won't be a problem even though we don't do protected instance variables anymore, because the derived class can also have access to our base class instance variables through the same public accessors. And then we display the employee using a toString method, and again note highlighted that we are using the public properties, and therefore we are calling the public accessors the get methods instead of hard coding the private variables in there. That would of course cause a problem when we try to override this method as well. And then the derived class base plus commission employee inherits all the instance variables, but does not have direct access to the private ones, but it also inherits the public properties, so it can use that. So our base plus commission employee now inherits from commission employee, has a 6-parameter constructor, but it uses it uses a private base salary attribute, and it sets the base salary public property, which is shown here. And then when we modify earnings, then when we override earnings in our definition, we need to have access to the base class's earnings, but we do because it's a public overridable method, and because it was declared virtual. And then we again use base salary, we use a public property instead of private data members of private attributes. And when we do the toString method, again we are using base salary as a public property in our implementation. And this is common that when we do method overriding, the base class part does a portion of the work, and then we add to it, and in doing so we use the keyword base and member access, like in the example for the earnings method. Base.earnings indicates that the base type objects original earnings methods are called, so that would be commission employee earnings, and we add to it in our overriding of the earnings method. So we are referencing the base class methods, and then we modify it in the derived class. It's important to do this, otherwise if we leave out the base dot, then earnings would end up calling itself, so it automatically assumes the derived class version, and if earning calls itself, that can create an infinite recursive loop, and therefore sooner or later lead to a memory overflow, a stack overflow. So this is our new implementation, and here is the test thing class with the main method, and we are referring everywhere to the employee's attributes, his first name, last name, and so on, by public properties. And when we change the base salary, we use a public property, and then the toString methods and the earnings as before, leading to the same output as before. So this is the best implementation of inheritance here. So our base class is commission employee, and again we are using private attributes instead of protected. So that guarantees that anything we do here and implementing here involving these instance variables will never be overridden, changed, and in any unsafe way modified by any derived class, because the derived class will have to rely on public properties, and those include validity checking and so on. So there is a 5-parameter constructor as before, and then they are public properties. Some of them read-only, some of them are not, but those that not have a set method have validity checking. And then the virtual earnings method that relies on public property accessors, and the toString method as well. And then the derived class, the base plus commission, that's the derived class is here, the base plus commission employee is derived from it. So base plus commission employee inherits from commission employee as base class, and adds a still private base salary. And note that in this case there's no difference between the access modifiers between the base class and the derived class. In the previous case the base class said protected and the derived class said private, and it was kind of any logical difference between the two. That's no longer the case, because both of them use private, which is the safest and really the appropriate way of defining inheritance. And then has a 6-parameter constructor as before, and defines a public property get and set methods for base salary with validity checking, and calculates earnings. So this is an override. So we're overriding the earnings of the base class, but in doing so we rely on the base class implementation of earnings. So the commission portion comes from the base class, and we simply add the base salary to it. So part of the work is done by the equivalent method in the base class. As I mentioned, leaving base.out would make it, however, an infinite loop, as without it earnings would call itself, and then again and again and again, creating an infinite recursion, which would lead to a Stack Overflow. And the toString method likewise relies on the toString implementation of the base class and adds to it the base salary. And that completes that. And then to test, there is a program as before. The test harness didn't change. We create and display an employee, then we modify the base salary, and then we redisplay the employee, this time using the toString method, as well as the earnings. So let me clean the solution just to be certain that there's no old code hanging around, and rebuild it. That forces a complete rebuild. Even files that haven't changed are going to rebuild, and that's the safest that we can do. So since that completed, we can Ctrl F5 to test the code, and there is the output of the by now familiar Bob Lewis employee display. And the first set of outputs is the item by item display of Bob's data, and the second one is the updated, in which we change the base salary and then use the toString method, which is a slightly different format, like the first name and last name are next to each other on the same line, and so on. And it's successfully completed, and this is the right way actually to handle this kind of inheritance relationships, so that the base class can stay with private instance variables and then use provide public accessors and mutators in form of property to its attributes, and virtual methods that rely on these public accessors, and its own method overrides also rely on the public accessors. So that will create the best version of this program. A few more words about constructors in derived classes. They always invoke its direct base classes constructor, and this ripples upwards in a class hierarchy, either explicitly or implicitly, and all the way to object. And to recap, inheritance is the idea of extending of an existing class or absorbing its attributes and methods, and the derived class inherits all the members of the existing class, data members and method and function members alike, methods alike, and the purpose of extension or inheritance is to customize the class by adding additional detail and by overriding base class methods. Independent software vendors can thereby develop or sell proprietary class libraries, and then new classes can rely on those. It can be done without accessing the source code. However, often developers want to have access to the source code when they buy a class library to understand how they are implemented and whether they are well implemented indeed and they are secure. Inheritance is the main tool of object engineering to achieve software reuse, and the software reuse is very important because it basically says don't reinvent the wheel, shortens development time, and makes sure that only well-tested and reliable code is used. And available class libraries maximize reuse. When we design, we should look at our classes, and if there are similarities between them, we should factor out the commonalities and move them up into a base class. So we should capture the commonality among classes and move them in a base class instead of repeating them in independent classes. And when written, the derived class code never affects the base class source code, but when written, the base classes implementations can change without affecting the derived classes. And the object class is the root class of all class hierarchies in C#, and it has some built-in methods that can be overridden in any class. These are by default virtual. One of them equals, which tests the equality of two objects. Another is finalize, which performs a garbage collection. In other words, it releases used memory when an object goes out of scope. There's a hash table handling method. Every method has a type and we can get it. We can clone member-wise, in other words, performing shallow copy. There's a reference equal, and there is the already well-known toString method. And that's the end of this segment.